Okay. If you have some problems to hear me, just raise your hand or leave a comment with message. Okay, so I'm going to start thanking you for being here. We are really thrilled to that our work is creating so much interest in the community. So the project that we will be presenting today was launched about 1 year ago, and it's carried out by a consortium composed by the French National Natural History Museum, Carbone 4, and the French Biodiversity Research Foundation. As you already know, the main objective of the project is to develop a method based on biodiversity-friendly practices ranking, which allow the assessment of biodiversity gain achieved thanks to expert consultation and consensus building. So the presentation will be split in 2 parts. First, Romain Juliard, a researcher in the Ecology and Conservation Sciences Center at the French National Natural History Museum and director of the Mosaic Laboratory, will introduce you the context of the project, the baseline hypothesis, and our methodological proposal to assess biodiversity-friendly practices effectiveness. Then in a second time, Flavie Thévenard, a data scientist at the Mosaic Laboratory also, will present you the whole experimental process that will take place on the platform and that will allow to collect the evaluations from the experts. So you will be able to ask questions at the end of the presentation by raising your hand, and I will activate your microphone. Okay, so let's start with Romain. Julia.
Thank you very much for being here. So as Matthias just said, this project is an ongoing project, and the reason for this talk is to it's the right time to have communication feedbacks, and if you are willing, so at the end of the presentation, to be prepared to participate to this project, because the success will depend on the large participation. It's part of a larger project, methodological development around biodiversity certificates, methods to get private funding for nature conservation. We will not detail this part of the project today, but if you have questions about that, we will be happy to have a discussion in another time. Please contact us. In the course of this project, we needed to develop an evaluation practice, an evaluation method for assessing biodiversity gain of a biodiversity project, and this is really what we want to present today, because we are very excited by the potential of the method we have in mind, and it's really time to discuss. So we are in the 2/3 of the project, about to develop and release this platform, and I will, as Matthias say, sketch out really the context of this methodology, and also the underlying hypothesis. So really what we want to assess is how to evaluate biodiversity gain of biodiversity projects, which is located somewhere in a given area for a given time step. So what's the gain of biodiversity projects between two time step? There's diverse methodology for that, lots of work going on here and there worldwide. The different methodology can be split into 3 families of methods. One is, of course, direct assessments of biodiversity, going in the field and by diverse methods to have biodiversity assessments at the beginning and at the end of the project. Another widespread developed method is to model the state of the system and to evaluate change in the state of the system and thus change in the gain in biodiversity through this modelization, which usually incorporate the different pressure on biodiversity as well as land use, land cover, and put that into a model for evaluating this change in biodiversity. And the last family of approaches is to what we call practice-based approach, is to assess the gain of a biodiversity of a project through the practices and through the efficiency of these practices. And this is exactly what we decided to follow. What's our choice? To have a kind of reference grid of biodiversity-friendly practices that are ordered, ranked according to the expected biodiversity gain. This method has several benefits, we believe. One is that if it exists, if you have this reference grid, then it's pretty easy to use. It's not costly. If you have the grid, you can check that some practice are in place, that they have been there for enough time, and from the grid, evaluate the gain of a biodiversity project. We'll detail all this, and it's hopefully will become clearer. It's easy to communicate because practices is really what's in the hand of people, what they do. It's easy also to address, to maintain, to upgrade, because there is no strong complex hypothesis underlying that. Each practices can be assessed on an individual basis. It's also a method that is really in the hand of people, and that's what we believe. That's also a kind of property of this method. One is that the practice should be defined by those who will implement them. So the practitioners, the land manager, farmers, if you are in farmlands, forest people, if you are in forest, conservation people, if you are in conservation areas, but they're really the one that will implement these practices. And the other people that will be involved is the biodiversity experts, and we will come to that in detail because that's really the point of this presentation today. There's really a two-step in this method. One is to establish this biodiversity-friendly practices taxonomy. A taxonomy is an organized list that is streamlined, defined in a standardized vocabulary that can be used in a generic way. And a taxonomy of practices is basically a list of practices that are recognized for their potential for biodiversity. And they are organized such that each practice is broken down into different levels of implementation, which is really the ambition of the practitioners with respect to biodiversity. And what we are targeting is to have this taxonomy based on reduce number of practice of actions. The target is around 15 practices per socio-ecosystem, and each of them is broken down into levels with up to 5 such level. This is an example of such taxonomy, which is already existing. That was really a source of inspiration based on this tool, Agribase, that has been developed for farmers in France for an auto diagnostic of their how their farming system is indeed biodiversity friendly. And there is 15 of these practice, like this is one of them, the management of grass strips. And as you see, there is different levels that have been defined. And this is really what we have in mind when we speak about level and level ambition of a practice. The hypothesis, the underlying hypothesis is that the biodiversity project can be split into practices. So that's really a simplification. That complex project like the one you have on the screen can be described, in fact, by a series of a limited number of practices that have been implemented. So this project here, this theoretical project, is a mixture of change in the soil management, implementation of grass strips, change in water management, and implementation of hedgerows. And you have different level of ambition that are pictured here in this small cartoon. And the other underlying hypothesis is the biodiversity gain can be assessed through this reference grid by the difference, the change in the level of ambition of these practices through time, and so that you can evaluate biodiversity gain with this reference grid. The second step is really, and it will be detailed by Flavie just after this slide, is to evaluate this biodiversity gain of these different practices through biodiversity-friendly practices ranking. There is again some underlying hypothesis, and one is that ranking practices is evaluating the expected gain, all other things being equal, on average, given in an average landscape, all things in average. And we'll see that already we will discuss this hypothesis and let some freedom on that. A key aspect of that is that we hypothesize that a large number of biodiversity experts are able to give this rank biodiversity practices. And biodiversity experts are people like many of you likely that have skills in ecology, in biodiversity science, and apply them either in the research or in the field, and have this through their expertise, this intuition, this assessment, this empiric knowledge that in a given landscape, in a given socio-ecosystem, like farmland in some place, like exploited forest, there are some practices that are efficient there. And by being efficient, it means that some are more efficient than others. And this is really what we want to grasp in this ranking process. And at this step, we have developed a platform interface to allow experts to rank these practices. And so for this to become clearer, let's Flavie now detail what we have in mind with this platform.
So I'm going to give you a tour of the experimental sequence. It can be divided into 4 parts. 3 of them are ordered, and the last one is just a way to know the experts. And actually, I'm not going to detail the expert categorization, and I'm not going to go into the questionnaire. The first part of the sequence is the in-practice ranking. So we are going to take a view at the levels and space them relatively to their gain in biodiversity. Then we are going to run the practices in between each other. And then we are going to tune the model with influencing factor and assigning correlation. First of all, I want to make a point on why we choose expert statements and why we choose relative positioning. As Romain has said, experts, we do believe that experts have strong intuition into which practices are better than others. And sometimes those intuition can't be confirmed by the field measurement because of the hazards of the fields. And these methods also allow to identify correlation between practices and context that couldn't be measured in reality because of the complexity of the combination. And it's also a way to get rid of separating the subject into quantified parameters, because as we know, biodiversity is an holistic subject, so it should be considered as one and not separated into different categories. The interest of relative positioning is that we can get a quantitative results by only ordering practices, because the position of the points in between the edges, the least good level of the least good practices, give numerical coordinates that can give a number, that can give a numerical value. So the first step is ranking the level inside a practice. So I'm sorry, the display will be in French because I didn't have time to translate them. Donc first of all, this is a practice which is an organical matter in the soil. And we have this practice with level 0, level 5, and all other 4 levels, which will be displayed as such, with the levels on the side and the ranking on the left side. And we will be asking the experts we will be presenting the practice with an even spread level, and we will be asking the expert to move the level horizontally. And the objective is to restore a relative spacing that corresponds to the transition from one state to the next. And one example could be that, and in this example, going from level 0 to level 1 is not as good in biodiversity than going from level 3 to level 4. And it's important for us that you could space differently each level, because levels are not equal in what we ask of them. So once they have ranking their level inside the practices, they can either, if they can't rank the levels, they can say that they don't have the knowledge for ranking these practices, and the practices will be out of the set. And if they have ranked the levels, they can give us their confidence into the evaluations they've just done. The confidence level is important for us because it encourages scientists to take risk. It gives us a level of reliability, and it can construct confidence intervals. So they will see each practice in this step, and then we are going to the next step, which is ranking the practices between each other. So we have the list of the 15 practices, and we are going to ask of them to select the practices that has the least potential of biodiversity gain. And then they are going to select the practices that has the greater potential of biodiversity gain, considering the practices as a whole, so from level 0 to level 5. And then it will be like the first exercise, it will be the least good, the best one, and all the other in between. And you have to, again, reorder the practices to give us the difference between each practices. So that could be a result. And we are going to enter into the final rendering of the assessment. So in this screen, we can see each practices, which is the prior arrangement of practices. So we have said that the practice 15 is the best, and also the practice 15 is the worst. This is an error on my part, sorry. And then we have the levels that have been priorly arranged of the 15 practices, and this is the grid of one expert. And the last action you have to do is to position this, which will either expand the levels or reduce them. As an example, I can show you if I put it on 70%, then all the least expected gain practices have levels that are way more spread. And then we can see that the best level of the least good practices is now at the same level of some other that were above it before. So this could be the rendering for one evaluator, and then we will build a consensus on multiple assessments. The consensus is measured by the concordance of the assessment. The gain is correspond to the average value of the gain assessed, and the standard deviation depends on the dissimilarities and the assessor's certainty. So this could be a final rendering of all evaluation into a simplified version. And for now, we have only considered practice separately, but it couldn't be effective in reality if we didn't consider practice in their context and practice in between each other. So this is what we are going to do in this first step, which is assigning a correlation to the practices and to the context. So for example, if we do believe that practice can benefit each other, and then the gain should be greater than the sum, and they are synergistic, or practice can be detrimental to each other, and then the gain should be in between the mean and the sum, and the practices are redundant. And also, it's obvious that practices are dependent on the spatial context, which can be physico-chemical or climate or landscape. So, for example, this is how we will ask them to show us the synergies in between practices. So in this example, we are in the practice number 1, and we will ask to position the other practice depending on their relation to the practice number 1. For example, like that. There is a possibility to not take a stand and just leave the other practice out of the ranking. And when we go to the second practices, we are suggesting a symmetrical relation that is not an obligation to keep. And then once they have done the synergy for each practices, which is not an obligation, you can choose to not do all the practices. We are going to ask them to express the influence of the context on the practices. So in this example, we are back on practice 1, and we are asking, how is the practice influenced by a really dry context or really humid context, which are separated into the repartition of fields. And this could be an example of response. So this is it for the experimental sequence. We should, at the end of the project, we should be able to deliver a protocol for reproducing a grid of practices, because the experimental sequence can be repeated for each ecosystem. We will also deliver a data collection system, which is the display that you've seen. We will deliver instruction on grid update, 2 use cases for farming in temperate forest, a map of the challenge of opportunities for biodiversity markets, and recommendation and certificate delivery and usage. So thank you for your attention.